Sorry, I had to take a break. I just had a flapjack cookie. It was really good. Anyway, so this second example shows you in a roundabout way the difference in the kind of sample size and being more reliable as well, I guess. So a supermarket is saying that apparently 25% of his customers pay by credit card. Test this claim in each of the following cases. Okay, so notice there, again, the first thing that we need to do is write down our null and alternative hypotheses. There's no mention of there being an increase. Somebody thinks that more people use credit cards, some people think it's less. They just said, test, is it yes or no? So this is one of those cases where, yes, okay, we'll assume that the proportion of people using credit card is 25%. And we want to check, so alternatively, I just want to check that it might not be 25%. Don't know if it'll be bigger, don't know if it'll be smaller. So we always set up our hypotheses first, even before we collect any data or anything like that. And so we haven't specified there greater than or less than that 25%, so it's got to be a not equal to. So part A then, we'll have a look at this. In a random sample of 50 customers, it was found that 9 of them used credit card. So here then our test statistic, X, the test statistic is a number of people using credit card. Number of people using credit card is our test statistic, which is X. Our significance level, there's no mention again in the question, so we just assume that alpha, our significance level, is 5%, which is 0.05. So again, if we get a p-value, if the probability of our sample happening is less than that, then we say, yeah, that's too unlikely to be true, really. So we'll probably reject our original assumption, which is that H0 is true. Collect suitable data. So yeah, our test statistic was the number using a calculator. So in this case then, we asked 50 peeps, 9 of them, so the number of people using credit card, which is X, was 9 of them out of 50, and therefore the number of people using credit card here is a binomial distribution. We asked 50 of them, and we'll assume that, again, at 25%, that the supermarket is correct. And then we'll see how likely our sample is of happening. If they're telling the truth or if they're telling porky pies. So in this case then, just note that, well, you would expect is more important in this case, because I don't have a less than or a more than in the H1. I need to know when I'm thinking about probably being more extreme than a value. Which side am I of what I'm expecting? Well, 25% of these 50 people, 25% of these 50 people is 12.5. I would expect about 12 or 13 people to be using credit card out of 50. I got 9, which is less than what I was expecting. So if this 25% of people, if the supermarket are wrong in their claim that 25% of people use credit card, then it's actually because they're too high, that we should be expecting less. But we only know that now, so we can't change our H1. We know that now, that we should have been expecting less, because it's actually a smaller value than what I was expecting. But actually, it may not actually be that far away from 12.5. 9 might be, fairly standard. You don't know. So we will then conduct our test and evaluate our findings. So conducting the test then, here we go. This just means find your p-value. So your probability now then is the probability of getting your sample or even more extreme, so even further away from what you were expecting. Now we have to multiply this one by 2. Because we weren't specific in our original assumption that our H1 was just either way. It could be greater than, it could have been smaller than. So to show that and to kind of remind ourselves that this could quite easily, this 9 here could quite easily be in a number bigger than 12.5. It could have been 15 or 16. We didn't know at the start. So we've got no right to just assume that this is a one-sided, the probability x is less than or equal to 9, because we weren't looking for a decrease at the start. We weren't saying, oh no, I think it's less than 25% at the start. We were saying, okay, it could be either way. I don't know. It could be 25%, it could be less, it could be more. I don't know. So to just kind of show that, we need to now double that probability, because it could have quite easily have been the other side, and it could have been a greater than. So whenever you've got a not equal to in your alternative hypothesis, you will always multiply your p-value by 2. That's very important. Anyway, that's 2 times then the probability of x being less than or equal to 9. Then in your tables on your calculator, x is 9, n is 50, p is 0.25, and you get 2 times 0.1637. Oh, that's actually 0.1637, which comes out as 0.3274. Well, that's actually quite high. Yeah, that's larger, that's greater than 0.05. I'm thinking now, in the first example, did I don't think I'd said that, did I? Didn't give the reason why. Yeah, sorry, should have said here, well remembered, that p-value was less than 0.05. Should have said that at the start. That's why I rejected H0, because it was too unlikely. In this case, my p-value is a lot bigger than 0.05. That's actually quite common, 32%. That's quite common. Okay, meh. Well, they might be right then. They might be right. Interpret the results then. So therefore, because my p-value is greater than 0.05, I would just say there's not enough evidence to reject H0. So again, I'm not saying H0 is true, but I'm just saying, okay, there's not enough evidence to reject it, because from my sample, there was a 32% chance of it happening if 25% of people were using a credit card. So that's still quite likely, actually. So yeah, it may be true. It may be true. They may be telling the truth. So I'm just going to say I don't have enough evidence to reject H0. So therefore, something in context as well. Then, like, we can assume that 25% of people use a credit card in this supermarket. Something like that. Okay. So part B now, then, all that changes is that they change the sample size. So they ask 160 and 28 of them pay by credit card. So N is 160. The number of people that pay by credit card is 28. So it's 160. So my binomial tables are going to change a bit. But I still assume, right, I'm still going to assume now then that the supermarket is right on the 25% of people. I should be expecting 25% of people to be using credit cards. So 25% of 160 is 40. So I should be expecting in this sample around about 40. All right, I'm not always going to get 40 bang on. Might be 30 odd, might be 40 odd, might be 50, might be 28 maybe. Is that too far away from 40? Is that a lot lower? Oh, that's lower than what I'm expecting. Okay, it's even, yeah, okay. That is quite far. That's quite far away, I think. Oh, well, it may be, it may not be. Let's have a look. How likely are we to get 28 or something even less than 28 if 25% of people use credit card out of 160? So if I'm expecting 40 people, how likely is it to get 28 or even less using a credit card? Well, again, binomial tables, N is 160, P is 0.25, X is 28. 0.08, and that comes out as 0.0153. So I times that by 2 again because it's not equal to in my alternative hypothesis. Could have quite easily have been more than 40 people. I didn't know at the start. Well, that's only a 3% chance. Only a 3% chance. Only a 3% chance of that happening. That's small. 28 is a lot lower than 25% of people. 28 out of 160 is a lot lower. My p-value there is less than 0.05. There's less than a 5% chance of H0 being true. Less than a 5% chance. So therefore, I would say that I've got strong evidence to reject H0. And in this case, so instead of just saying what H1 means, instead of just saying, so therefore the proportion of people using the credit card is different, 25%, I actually know that because my value was less than what I was expecting, so it's likely, it is likely that less than 25% of people use a credit card. There we go. Thank you.